Hello, my name is Rohit Prasad. I'm a student of Veltech University. We are doing a project on relay coordination between station and service transformer in GMR power plant. My batchmates are, my one batchmate Rahul Kumar Pandey, and another batchmate is the one who is recording is Avinash Kumar Baranwal. From now onwards, my friend Avinash Kumar Banwal will explain our abstract.
The main abstract of our project is the protective relay must be able to discriminate between fault condition and normal condition. And the term of relay coordination covers the concept of discriminating selectivity and backup protection. The relay coordination calculation module must consider the operating characteristics of the relay, normal operating and mechanical, withstand the characteristics of the equipment. So thereby we need to protect the system by relay coordination, ensuring continuity in the supply through simulating using ETAP software.
So now we will explain our single line diagram. You can see that there are three main buses, one of 110 kV, one second of 6.6 kV and third of 0.415 kV, and two transformer. One is service transformer and second one is station transformer. The station transformer converts 110 kV to 6.6 kV and service transformer will convert 6.6 kV to 0.415 kV, and at the same time we have four relays here. Relay 1, relay 2, relay 3, relay 4. Suppose a fault current occurs or fault occurs at the position of relay 1. So relay 1 will operate, then relay 2 will operate, then relay 3 will operate. The main problem comes when the fault occurs in between any two relays. Then the relay selectivity and discrimination comes in the picture. So if a fault is in between R1 and R2 and it is nearer to R1, then we will provide a certain time settings so that R1 will operate first and then R2 will operate. So by that we will give a relay coordination so that accordingly they will work. And next we will explain this in ETAP.
Now as you can see, we have launched ETAP version 7.0. I'm going to design the circuit. I will just show the outline of the circuit, then we'll show you the how to insert the values. So like this, we have taken a bus from here. I'm taking a transformer from here. We have to take a feeder which will feed the bus, and then we'll take another bus. We'll take an overcurrent relay, we'll take a current transformer, and we'll take a circuit breaker. Now how to connect these things? We are connecting just by joining these two. Connect the circuit breaker, we can do it like this.
But for connecting our current transformer, for connecting of relay, we have to give a current transformer.
Now as you can see, we have just designed the model circuit. For inserting the values, we can double click on them and we can show the values. Now you can see, as we have designed the whole circuit, this is the feeder, this is the two bus. It is joined by service. These two are station transformer, these two are service transformer, and we have introduced few circuit breakers over here, and these are the relays, overcurrent relays. This is the current transformer. This is a motor of 300 horsepower. This is the three bus 1 110 kV, bus 2 6.6 kV, bus 3 of 4.415 volts kV, sorry. So now here I'm going to show the load flow analysis. Now here you can see the values of load flow,
which are red in color. So you can see the impedance values which are given by J, and similarly the current will flow from upside to downside. And now we will show you how we will put the settings of each and every device. First we will see how to put the value in feeder.
the feeder actually automatically takes these values. We don't have to insert over here. We have to first configure the bus. In the bus we are taking IEC settings and we are taking typical data,
and other things are automatic things. We don't have to do much, put much. So we can take from library.
Initially we have to just put 110 kV over here
And name is bus 1.
Now Similarly, by double clicking on the relay, there is a good library over here from where we can choose. We have chose this IMPRS by ABPP. Here these are the type of curve, these are the ratings we have chosen over here.
So the curve type will be extremely inverse, which is nothing but will give the inverse relationship between the current and the time. So we will give our pickup range according to that, and then pickup value, and the time dial setting is automatic, that we cannot give. So from this setting we will move on.
Similarly, we can configure our current transformer. This is the rating which we are giving, 400 by 1. Similarly, for the rating, we can, as we told you, IEC settings we are using, we can choose from library, or we can put the values manually. This is the rated kV, rated ampere.
So similarly, we'll put the values for all the things. Now we will show you the short circuit analysis. So you can see the currents which are flowing in the circuits are red in color. So now we will create a fault. Though we can create a fault anywhere in the circuit, but for purpose of showing, we will create here near to relay 6. Now if suppose a fault current is here, then relay 6 definitely will operate first, then relay 5 will operate, and then relay 7 will operate, which we can see through a curve.
This is a unique feature of ETAP, or for creating a star view, we have to select the circuit and we have to click over here, and it will automatically feed us the graph. This is the graph. I will separate this over here.
Relay 4 and 6 are tripping first. There the time is the 0.169 second, and then relay 3 and 5 are tripping. The point is 0.556 second, and relay 2791 is not tripping for this fault.
Now we will show you this in circuit. We will explain our concept. So we can bring our circuit from here. So you can see the time ratings of operating time of two relays are same, which is 6 and 4, and at the same time the time settings of relay 5 and 3 will be same. We will not consider the relays which are on the upside, because we have to show the connection between these two relays. Suppose a fault occurs here below relay 6, then relay 6 will operate, relay 5 will operate, and the main problem will come when a fault is created in between 6 and 5, relay number 6 and 5. Then we have to give a setting which is pickup range of the currents. So we'll give pickup range of currents. Suppose a fault is nearer to relay 6, then fault current will be more. Then we have to, according to that, we will give a time setting which will be less, so it will operate first, then the current will go slowly upside, and the value of the intensity of current will automatically decrease. So relay 5 will get more time, so we will set according to the time setting will be according to that, and relay 5 will operate after relay 6. This is the main concept.
So as you can see the graph here, relay 4 and 6 are the first to cross this line. This is the tripping line. These two are crossing the tripping line. That's the reason it is tripping first and it is tripping at the second.
So you can clearly see from the graph, this is the curve for relay 4 and 6. They are tripping in a less time, so a certain very small portion is cutting this line, and in the above relay 3 and 5, a large section you can see which is cutting the tripping line. So because their time setting is greater than this 6 and 4th relay. So, and another concept can be explained by these. Suppose a power surge is there, then the relay need not to trip unnecessarily, because it will affect the operation and efficiency. So we will provide a certain time lag after which the relay should operate. So it will we will give a time lag. Suppose the power surge is there, then at for certain time the relay will not trip. So the power surge goes on. It will not affect the power system. So we can increase the efficiency and stop the unnecessary trippings. That is our concept, and we conclude from here.
Thank you.